Let's look at angles and how to define them. We can define an angle as two rays that share an initial point. So if I have this one here and this one here, we would have this particular angle. The point that they connect their initial points, this is known as the vertex. One side of the angle is known as the initial side, while the other side of the angle, the other ray, is known as the terminal side. One way to think about angles is as a rotation. We have our initial side, and we rotate it around to get to the terminal side. And that's another way to think about angles. We tend to denote them by Greek letters such as alpha. In this case, here's my initial side, and I rotate towards the other one. We'll call this one theta. And so the idea is we start with our initial ray and then rotate it to get to the terminal side. We do have a standard position for angles. For standard position, we need two things. We need the initial side to correspond with the positive x-axis, and we need the vertex to be at the origin. So here we can see an angle that is in standard position. We have our initial side right here along the x-axis, and the vertex does occur at the origin. We can think of angles as being either positive or negative. A positive angle has a counterclockwise rotation. So when I have it in initial position, I move counterclockwise. So this would be a positive angle. A negative angle has a clockwise rotation. So when I put it in standard form, a standard position, it moves clockwise. This would denote a negative angle. When I think about my coordinate plane, I have 4 quadrants. The top right is the first, and moving counterclockwise, we have the second, third, and fourth. And we can define angles by their quadrants as well. Wherever the terminal side resides, we can say the angle lies in that quadrant. As an example, this angle here, we can say lies in quadrant 1, since the terminal side is in the first quadrant. Meanwhile, this angle here, we can see that its terminal side lies in the third quadrant. So we can say that this angle lies in quadrant 3. So we can define angles based on which quadrant their terminal side resides in. It is possible that our angle doesn't lie in any quadrant, but instead along either the x or the y axis. These angles are known as quadrantal angles.